Alright, so today we want to utilize a potential energy curve to determine forces acting on a given particle, the motion, and then also the speed of a particle. So to begin with, we are given that the particle starts at x equals 3, the mass of the particle is 5 kilograms, and we want to find the speed of the particle at x equals 5 and the force at x equals 6. So here's a little overview of our little diagram, energy versus distance diagram. So we have the initial location is at x equals 3 right here. And so if the particle was to start at that particular point, it would not have enough energy, momentum, or force to overcome this hill. It would just go down and then up and then stop, and then it would come back down if we're assuming that it's frictionless. If it was frictionless, it would not quite reach this this top of this peak here where it has zero kinetic energy. So because the bounds of it are from x equals 3 to about x equals a little less than 7, it's just going to like constantly go back and forth. So we want to know the velocity of the speed of the object at x equals 5. So we're just evaluating from here to here. Right here at the bottom of bottom of this well, this little canyon is 5 joules, and then the top is 10 joules. So 10 minus 5 is 5. And we go over here to kinetic energy. K equals 1/2 mv squared. Doing a little rearranging and solving, we find that the velocity is 1.41 meters per second at the bottom of the hill. Let's see, what else do we want to find? We want to find the force at x equals 6. So if we assume that we start at x equals 3, and we're going from left to right, so at x equals 6, let's see if I can point at x equals 6, we're about, let's see, we're about right there on this curve, right there. We're about right there. So I estimated that we go up 1, which it would be, let's see, we go from 8 to 9, so this is 9 joules, and then we go over, so here's 6, distance, x equals 6, and here's x equals 7, so I estimated 0.2 meters. So we come over here, and so we find that the rise is 1 joule in energy, and then we go over 0.2 meters. So that's equal to 5 newtons. So since we're going from left to right, we're still going uphill at this point until we reach around x equals 6 point something, until we have zero kinetic energy. But we have a -5 force acting on the object in the x direction, which is key. And therefore we have satisfied all of the questions that the question has asked us.